Hi scholars, let's look at TEK 4.4F. I can use strategies and algorithms, including the standard algorithm, to divide up to a 4-digit number by a 1-digit divisor. So this video is only focused on standard algorithm for long division. I'm going to start with 2-digit divided by 1-digit, do 3-digit divided by 1-digit, 4-digit divided by 1-digit. So let's get started. Before we get started, these are the steps for long division, and I always remember it by does McDonald's sell cheeseburgers regularly? Now, the first section is you're just going to go through the steps once, and so you will not do the bring down or repeat steps. You will just divide, multiply, subtract, check, and then whatever's left over is your remainder. If you have to go through the steps again, you're going to do divide, multiply, subtract, check, bring down. Repeat your steps, and then you'll do divide, multiply, subtract, check, bring down, and then it'll be remainder. But if you end up repeating again, you go through it again. You keep repeating until you have nothing left to bring down, and then it's your remainder. So you're going to be hearing me, using that terminology again and again through the video, so just be familiar with it. Okay, let's look at this. This, you're going to go through the steps twice, so it's really important that you master the first few clips of video I showed you before you look at this video. So now you're not going to do 2 goes into 37. You're going to do 2 goes into 3. So 2 goes into 3 one time. Okay? Because this is the closest to 3 without going over. So 2 times 1 is 2. 3 minus 2 is 1. Okay? Now, you've been doing the divide, multiply, subtract, and all that. Now, when you're done, there's a step called bring down. You bring down the 7. And now you're going to do 2 goes into 17. I usually tell my scholars when they're first learning to make this a new division problem so it'll help them. So I'm like, now think 2 goes into 17 how many times? So 2, 4, 6, 8, 10, 12, 14, 16. So that's 8 times. So you're going to put the 8 up here. You're going back to the beginning. 2 goes into 17 8 times, multiply. 8 times 2 equals 16. I have a lot of students that'll do 18 times 2. Don't do that. This one, you're done using it. It's 8 times 2 equals 16. Because you're saying, I want an array where there's 17 in it and there's 2 on the side. So you're telling them, well, the best I can do is an 8 by 2, and it'll be 16 in that array. So when you do 17 minus 16, you'll have 1 left over. Okay? And so then it's 18 remainder 1. Okay, let's do another one. 3 goes into 4. The closest to 4 without going over is this one, so it'll only go in 1 time. So that's my division. My multiplication, 3 times 1 is 3. Subtract, 4 minus 3 is 1. So usually everyone's pretty good on there, and then the next step is bring down that 6, and now you have to do 3 goes into 16. Okay? The closest to 16 is this one. So 1, 2, 3, 4, 5 times. Okay? So that would be 15. So you put that here. 16 minus 15 is 1. So my answer is 15 remainder 1. So if you look at this as a whole, you're saying, well, if you want 46 in here, the best I can do is a 3 by 15, and a 3 by 15 equals 45. And so then, you want 46, so then you'll have like 1 left over. And that's where 15 remainder 1 comes from. That's what's being modeled here in this division problem. All right, let's look at this one. This one is 96 divided by 8. 8 goes into 9 one time, okay? Because if I do 2, then that's 16. Well, 16 is more than 9. So 1 time. 8 times 1 is 8. 9 minus 8 is 1. Bring down the 6. Now you're doing 16 divided by 8. 8 goes into 16 actually perfectly twice. So 2 times 8 equals 16. 16 minus 16 equals 0. So my answer is 12. And in this situation, if they say, well, I want an array and I want 96 in there and I want 8 over here, you can say, well, a 12 by 8 is perfect. 12 times 8 is 96. So that works out perfectly. There's no remainder. Okay, let's look at this. 56 divided by 3. So don't do 3 goes into 56 how many times? Do just 3 goes into 5. So 3 goes into 5 one time. So there's my division, my multiplication. 3 times 1, and sometimes I tell students to do this to help them remember. 3 times 1 is 3. 5 minus 3 is 2. Bring down that 6. Now I'm doing 26 divided by 3. Looking at this list, 24 is the closest. So that's 1, 2, 3, 4, 5, 6, 7, 8 times. 8 times 3 is 24. So you can see I did 8 times 3, not 18 times 3. 26 minus 24 equals 2. So 18 remainder 2. Okay, let's look at another example, but this time we're going to be dividing into a 3-digit number. So 2 goes into 8 4 times. 4 times 2 is 8. 8 minus 8 is 0. So then you bring down the 2, and now you're going to do 2 divided by 2. 2 goes into 2 one time. 1 times 2 is 2. 2 minus 2 is 0. Bring down the 3. 3 divided by 2. 3 divided by 2 is 1. 1 times 2 is 2. 3 minus 2 is 1. So my answer is 411, remainder 1. This is really easy. You just have to keep following the pattern. Make sure you go do the steps in order. Make sure you put the numbers in the right spot. Let's look at another one. 654 divided by 3. 3 goes into 6 2 times. 2 times 3 is 6. 6 minus 6 is 0. Bring down the 5. 5 divided by 3. 3 goes into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. So usually students are okay here, and then they get stuck and they forget they have to bring down another number. So now it's 24 divided by 3. 3 goes into 24 8 times. I'm using this as my guide. Put 8 at the top, and I always just kind of connect the 8 to the 3 to remind myself to multiply. 8 times 3 is 24. 24 minus 24 equals 0. So 218, remainder 0. When you have nothing left here to bring down, that's when you know it's your stopping point. But like, let's say there was like a 5 here and I got 0. I have to bring that 5 down and repeat the steps again. Okay, so 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. Bring down the 7. 17 divided by 4. 4 goes into 17 4 times. 4 times 4 is 16. 17 minus 16 equals 1. Bring down the 9. 4 goes into 19 5 times. 5 times 4, actually, I take that back. It goes in 4 times. 4 times 4 is 16. 19 minus 16 equals 3. So it's 144, remainder 3.